All right, let's go ahead and try something that's a little bit different from that one. So we have 2 dice. We want to roll the sum of a 7, but we're going to stop as soon as we roll the 7. So we get 3 rolls to do it, but we're going to stop as soon as we get a 7. So the way that this could go down is I could roll a 7 on the first one, and then I would stop. Or it could take me 2 rolls. It could take me that I get a 7 on the second roll. Or, and I'm saying or in writing, so I'm so used to translating the writing into the verbal into math that I wasn't even writing down the words. So this is an or. So I could get it on the first roll, or I could get it on the second roll, or it could take me 3 rolls to get a 7. And since it's an or, I'm going to be adding. So we have the probability that I get it on the first plus the probability that I get it on the second plus the probability that I get it on the third. So the probability that I get a 7, we already did this. We know that the probability of getting a 7 is 6 out of 36. You can bring back up the table if you need it. The probability that I don't get a 7 is the complement of that, so that's 30 out of 36. And so if I were to roll a 7 on the first roll, then I'm going to stop, and that chance of that happening is 6 out of 36. But then it is possible that I didn't roll. I did not roll a 7 on the first one, but I did roll it on the second. Or I didn't roll a 7 on the first 2 rolls, but then I did roll it on the third one. And then I would add all those together, and that would be the probability that I rolled a 7 and stopped as soon as I finished, given 3 rolls to do it. All right, so this last example here, we're gonna attack this in a little bit of a different way. So now we have 2 dice, and we are gonna roll it 6 times. We have 6 times that we can roll it, and we're just looking for the probability that I roll a 7 1 time. So that means I could roll it more than once. So this is I could roll a 7 once, or I could roll a 7 twice, or I could roll a 7 3 times, or I could roll a 7 4 times, or I could roll a 7 5 times, or I ran out of room, or I could roll a 7 6 times. Now, if we were to do this probability out, this would be the probability that I got a 7, and then the probability that I got no 7, and that probability happens 5 times. But I'd have to go through that for each of these scenarios, and that's going to take way too long. So we can think of the complement of getting a 7 1 or more times is that I never got a 7. Let's find the probability that I never rolled a 7 in 6 rolls. So the probability that I never get a 7, remember the probability of getting a 7 is 6 out of 36. So the probability that I don't get a 7 is 30 out of 36. So in 6 rolls, I have a no 7, no 7, no 7, no 7, no 7, no 7. So there's going to be 6 of these. I roll it 6 times, and out of all 6, I never get a 7. So this is 30 over 36 raised to the 6th power. That's the probability that I never roll a 7. Now the probability that I roll a 7 plus the probability that I don't roll a 7, probability that I get a 7 plus the probability that I never roll a 7, sorry, the probability that I get at least 1 7, let me write that out so that it's clear. The probability that I get at least 1 7 in 6 rolls plus the probability that I never get a 7 in 6 rolls is going to be 1, because these are complements of each other. Now I just found this. This is the 30 over 36 to the 6th power. So if I'm looking for the probability of getting at least 1 7, that's going to be 1 minus 30 over 36 to the 6th power. And again, you can just leave this. I'm more interested in your work than in your final answer. I'm going to split this video up so you can pick this up in the next one.